Are you repeating yourself by building the same features again and again in your functional components? Then in this video, we're going to cover the 5 custom hooks I use every single day in most of my React application and that you should start using. Those 5 React hooks will boost your productivity, speed up your development process, and save you a lot of time so you can work on more valuable features for your project or application. So let's dive in. What's up guys, this is Greg with AlterClass, helping you learn the right skills to learn your dream job as a software engineer. And if you are new here, make sure to like the video, subscribe to AlterClass, and consider becoming a pro member at AlterClass.io to learn everything you need to master React and become a successful React developer. And all the links to everything I mentioned in this video can be found in the description box below. So make sure to check this out. So now let's jump into it. React hooks have been introduced to the library with version 16.8. It allows you to use states and other React features in your functional component so that you don't even need to write classes anymore. In reality, hooks are much more than that. Hooks lets us organize the logic inside a component into reusable isolated units. They are a natural fit for the React component model and the new way to build your applications. Hooks can cover all use cases for classes while providing more flexibility in extracting, testing, and reusing code throughout your application. Building your own custom React hooks, you can easily share features across all components of your applications and even across different applications, so you don't repeat yourself and get more productive at building React applications. Right now, we are going to take a look at my top 5 custom hooks, recreate them from scratch together, so you really understand how they work and exactly how you can use them to boost your productivity and speed up your development process. So let's jump right into building our first custom React hook. How many times have you built a React application that needs to fetch data from an external source before rendering it to the users? Fetching data is something I'm doing every single time I'm building a React application. I even make several fetching calls inside a single application. And whatever the way you choose to fetch your data, either with Axios, the Fetch API, or anything else, you are always writing the same piece of code again and again across your React components and across your application as well. So let's see how we can build a simple yet useful custom hook we can call whenever we need to fetch data inside our application. This way we will be able to reuse the logic inside that React hook in any functional component to fetch data with just one line of code. Okay. So let's call our custom hook useFetch. These hooks accept 2 arguments, the URL we need to query to fetch the data and an object representing the option we want to apply to the request. Fetching data is a side effect, so we should use the React useEffect hook to perform our query. In this example, we are going to use the Fetch API to make our request. So we are going to pass the URL and the options. And once the promise is resolved, we retrieve the data by parsing the response body. For that, we use the JSON method. Then we just need to store it in a React state variable. Okay, but we should also catch and handle network errors in case something goes wrong with our request. So we're going to use another state variable to store the error. So we could return it from our hook and be able to tell if an error has occurred. Our useFetch hook will return an object containing the data fetched from the URL or the error if anything wrong happened. Finally, it's generally a good practice to indicate to your users the status of an asynchronous request, such as displaying a loading indicator before rendering the results. So let's add a third state variable to our custom hook to track our request status. We set this loading variable to true right before launching our request, and we set it back to false when it's done. We can now return this variable with the others to use it in our components to render a loading spinner while the request is running, so that our user know that we're getting the data they ask for. One more thing before we see how to use our new custom hook. we need to check if the component using our hook is still mounted to update our state variable. Otherwise, we are introducing memory leaks in our application. To do that, we can simply create a variable to check if our component is still mounted and use the cleanup function to update this variable when the component unmounts. And inside the promise methods, we can first check if the component is mounted before updating our state. Alright, now let's see how easy it is to fetch data with our useEffect hook. We just need to pass the URL of the resource we want to retrieve. From there, we get an object that we can use to render our application. Let's move into our second custom hook, useEventListener. This hook is responsible for setting up and cleaning up an event listener inside our components. This way, we don't need to repeat ourselves every time we need to add event listeners to our application. It accepts as argument the name of the event we want to listen for, the function to run whenever an event of the specified type occurs, the target under which to listen for the event, and finally, a set of options for the event listener. As with the previous hook, we'll use the React useEffect hook to add an event listener. But first, we need to make sure that the target supports the add event listener methods. Otherwise, we do nothing. Then we can add the actual event listener and remove it inside the cleanup function. Actually, we're going to also use a reference object to store and persist the listener function across renders. We will update this reference only if the listener function changes and use this reference inside our event listener methods. We don't need to return anything from this hook, as we are just listening for events and running the handler function passing as an argument. It is now easy to add an event listener to our component, such as in the following component, to detect clicks outside a DOM element. Here we are closing the dialog component if the user clicks outside of it. For our third custom hook, we will leverage the local storage of our browser to persist our component state across sessions. For this one, we need the name of the key to retrieve or update in local storage and an initial value. That's it. And we are going to return an array like the one you get with the React useState hook. So this array will contain a stateful value and a function to update it while persisting it in local storage. So let's dive in. First, let's create the React state variable we will sync with local storage. Here we are using lazy initialization to read local storage, parse the value if any has been found, or return the initial value passing as the second argument to our hook. In case something goes wrong while reading in local storage, we just log an error and return the initial value. Finally, we need to create the update function to return that is going to store any state updates in local storage rather than using the default one returned by the useState hook. This function updates both the React state and the corresponding key value in local storage. Note that we can also support functional updates like the regular useState hook. And finally, we return the state value and our custom update function. Now we are good to go and we can use the useLocalStorage hook to persist any data in our components in local storage. In the following example, we use it to store the application settings of the connected user. Okay, let's move on to our fourth React hook, useMediaQuery. This hook will help us to test and monitor media queries programmatically inside our functional components. This is very useful, for example, when you need to render a different UI depending on the device type or specific characteristics. So our hook is accepting three arguments, which are first, the array of string corresponding to the media queries, then an array of values matching those media queries in the same order as the previous array, and finally, a default value if no media query matches. The first thing we do inside this hook is building a media query list for each match media query. We're going to use this array to get the corresponding value by matching the media queries. And to do that, we are creating a callback function wrap inside the useCallback hook. We retrieve the value of the first media query in our list that matches, or return the default value if none of them match. Then we create a React state to store the match value and initialize it using our function defined above. Finally, we add an event listener inside the useEffect hook to listen to each media query's changes. And we run the update function when changes occur. Here, we don't forget to clean up all those event listeners and return the state value from our hook. A simple example I've used recently is to add a media query to check if the device allows the user to hover over elements. This way, I could add specific opacity styles if the user can hover, or apply basic styles otherwise. Okay guys, one more hook to go. This one is my favorite. It allows me to easily and quickly apply the dark mode feature to any of my React applications. Let's see how to build such a hook. These hooks aim to enable and disable the dark mode on demand and store the current state in local storage. For that, we are going to use two of the hooks we just built, useMediaQuery and useLocalStorage. With useMediaQuery, we can check the user's browser preference for dark mode. Then with the useLocalStorage, we can initialize, store and persist the current state, dark or light mode, in local storage. Finally, the final piece of this hook is to fire a side effect to add or remove the dark class to the document body element. This way, we could simply add dark style to our application. And if you are looking for an easy way to do it, once again, have a look at Tailwind CSS, which supports dark mode. Coupled with this hook, Tailwind CSS becomes the easiest and fastest way of implementing dark mode in any React application. Alright, that's it guys. Thank you so much for watching. I really hope that this video was useful for you. Make sure to check the description below for the link to the GitHub repository to get the source code of all the hooks we just built together. Please share this video with your friends, hit the like button, and please don't forget to subscribe. And check AlterClass.io if you want to go further and master React. I'm building the only course you will need to become a React developer and get that dream job. Thank you and see you soon.